In this video, I want to have a look at trigonometry in 3 dimensions. So these sorts of problems are using all the trig that we already know, so it might be our right angle trig or it might be the sine rule or the cosine rule, and applying them in this new context. So a lot of these questions won't give you a diagram, they'll give you a worded question and you need to be able to interpret that into a diagram and pull that diagram apart into its different triangles. So let's have a look at an example. So our example says we've got a tower, AB, and our tower is 80 metres tall. The angle of elevation of that tower from a point C, which is due east of the tower, is 45 degrees. From another point, D, the bearing of the tower is 30 degrees, and from that point, the angle of elevation to the top of the tower is 28 degrees. The points B, C, and D are all on level ground. So part A asks us to show that angle CBD equals 120. So to be able to solve this problem, I'm going to draw sort of a top-down view of this problem. So from directly above that tower. So that means I'm going to put a point here, and I'm just going to call it B. So that's the base of our tower, and it would come vertically upwards out of the page if we were trying to draw it. All right, so that's where our tower is. Now we've got a point C that's due east of that. So straight across here, whoop, that is not a straight line, but you get the idea. This is our point C. And then we've also got a point D. Now, from the point D, the tower is on a bearing of 30 degrees. So that means that our point D is going to have to be down here somewhere. We join those together. Again, you should be drawing all of these with a ruler so that they're straight lines. We've got our north line here. And this angle in here is 30 degrees. So our first question asks us to show that the angle CBD, so this angle here, is 120 degrees. So we know that this here is, C is due east, directly east of B. So that means if we drew in a south line here, again, should be straight, that this part here would have to be 90 degrees because this is due east, this is due south. We also know that south and north, they have to be parallel lines, which means that this angle in here has to be 30 degrees because it's alternate with that one. So that means that our angle CBD has to equal 90 degrees plus 30 degrees, which would give us our 120 degrees. To solve parts B and C, I'm going to draw up the 3D picture of our situation now, of our problem. So here we've got the tower, this is the top of our tower, so this is A, and this is the bottom of our tower, so B. Now, I'm going to draw our point C over here, and we know that the angle of elevation to the top of the tower from C is 45 degrees. By drawing my straight line there, we've got 45 degrees in here. Now point D, I'm going to draw over this way. Joining that on. Now we know that the angle of elevation to the top of the tower from D is 28 degrees. So that's going to be 28 degrees in there. We also just found out that this angle in here, so I'm going to move my B out of the way, this angle in here, from C to B to D, was 120 degrees. So we found that out in part A. So I'm going to draw my line in there. The other piece of information that we have is that AB, our tower, is 80 metres tall. All right, so part B asks us to show that BD equals this and BC equals 80. So to solve those, I'm going to do it as two separate things, and we're looking at two separate triangles. So to find BD, I'm going to draw up this triangle here. Sorry, one thing I left off those diagrams is because B, D, and C are all on level ground, these are both right angles in here. So if I draw in my triangle ABD, so just drawing our 2D version now, we've got our 80 metre tower here. This is D, B, and A, and we've got our 28 degrees here. So if we're trying to find the length of this side, we can just use our right angle triangle SOHCAHTOA. So this is our opposite and our adjacent side. So that's going to be tan of 28 degrees is equal to 80 over BD. And if we rearrange that, we're going to have BD equals 80 over tan 28 degrees. So that's this first bit shown. To prove this second bit, I'm going to draw in this triangle. So this one's already pretty clear here, but I'm just going to draw it again as our 2D version just to make it really clear what we're doing. So we've got B, C, A. We've got our, that's an A, not an 8. And we've got our 80 meters here and our 45-degree angle of elevation. So again, this is going to be our opposite and our adjacent. So it's a tan problem again. So we're going to have tan of 45 degrees is equal to 80 over BC. But tan 45, that's one of our special angle results. And we know that tan 45 is 1. So 1 equals 80 over BC, which means that BC is equal to 80 meters. So part C of our question asks us to find the distance between C and D. So that's the length of this side along here. And it asks us to answer correct to the nearest meter. So to do this, I'm going to draw that bottom triangle separately. So we've got B, C, D is over here. And we're trying to find this length of this side. Now we know that this is 120 degrees. We just figured out that BC was 80 and the length of BD was 80 over tan 28, whatever that works out to be. And we're trying to find this length CD along here. So for this one, it's not a right angle triangle, but our problem involves 3 side lengths and 1 angle. So we're going to use the cosine rule. So the cosine rule is C squared equals A squared plus B squared minus 2AB cos C. In our case, our C is our side CD. So we're going to write CD squared equals 80 squared plus 80 over tan 28 squared minus 2 times 80 over tan 28 times cos of 120. If we put all of that in our calculators, we end up with 41,074.29, and it keeps going. But to find CD, we need to take the square root of that. And if we round our answer to the nearest whole number, we'll end up with 203 meters. So this is our final answer for that question. So the whole idea of this is that we're taking a worded question and we need to be able to interpret it into a 3D problem and then pull apart each triangle within that problem to be able to solve it. So that's having a look at one example of trigonometry in 3 dimensions.